So the harmonic series, nature's blueprint for the musical notes. So when a string of air column, so let's just think scientifically now. So let's say later we got the hertz. Now we can measure the wavelength in hertz. So now we're going, oh, wait a sec. I can actually measure precisely scientifically the wavelength. So that's going to lead me to say, well, I would like to then see the harmonic series when you pluck the string, which we talked about before. What are the resonances that aren't just the main pitch, but the other pitches to it? And that's going to help give us a scientific reason as to why the 7 notes that were picked make sense, and why many cultures will pick similar notes, right? So when a string of air column vibrates, it doesn't just vibrate at one frequency, it creates harmonics. So this is what we talked about before, similar to dropping a pedal in a pond. It doesn't make just one wave, it makes multiple waves, one fundamental and then multiple other waves. Similarly, air compresses against each other, but it's easier to envision a wave, right? It's a compression wave, okay. But so fundamental, it has these fundamental series. So the first 7, 8 overtones closely resemble the structure of the major scale. So now you can say, so now instead of saying, well, Pythagoras is thinking like a religious person over there in a Pythagorean religious school, and he wants it to be like from gods or whatever that came up with the underpinning. But now we're going to say scientifically that the reason it happens is because you have these harmonic series. And again, I don't think there's anything wrong with the way Pythagoras was seeing it. This doesn't disprove the way he was seeing it, right? It actually proves that the way he was seeing it was right, although there would be arguments between the scientists and the philosophers in terms of what's the rationale, what's the actual underpinning thing that gives us the phenomenon that we've come to from 2 different directions, you know? But so this is not man-made; it's physical. Musical notes arise from natural resonances. So this would, once again, you would think, give us some restrictions from culture to culture. So notice other cultures might pick different notes, but they can't pick different notes that are going to be different past the octave. Otherwise, men and women couldn't sing together. No culture would do that, you would think. And you would think certain pitches, like the perfect fifth, for example, is pretty rock steady. That's as comfortable a sound that you can get. So you would think that no culture would really throw that one out, you would think, you know. So that gives you some restriction to say music isn't totally cultural, although clearly it has a cultural component in terms of the scales created. So the move to 12 notes equal temperament. So now later on, we're saying, hey, look, these 7 notes are great, but now that we can measure hertz, now that I can break the interval between the octave up into a series of measurable distances, wouldn't it be cool if I have units like a ruler? I want to make equal unit distance between the 2. That would make sense. That's what we would want to do. So now as music evolved, instruments needed to play in any key. The exact ratios weren't flexible. In other words, 7 notes isn't enough. I want to be able to switch keys and play in different keys. I want more crayons in the crayon box. So Western music adopted the 12-tone equal temperament system. So the octave is divided into 12 equal parts, semitones, and each note is the same distance from the next. So now we're saying, okay, now I can measure this thing. So now I'm going to break it out. I'm going to break it out by measuring the actual hertzes, right, into 12 equal units like a ruler. So now we have 12 equal units. Now, why did they use 12? They didn't have to, because you could imagine that you could put a system together that maybe was 24 or something might work or something like that. That's where the variance comes in. So now the question, so from culture to culture, you would think we're restricted by the octaves. We're restricted that the number of pitches that we pick need to have some resonance with the harmonic series. Scientifically, you would think they would have a perfect fifth, for example, would have to be in there because it's such a fundamental sound just to all human beings. And but then you could have some variance in terms of how many pitches you're going to basically work with, right? We had 7, and now we're going to have 12. 12 pitches, but you could imagine 24. That would be a lot more colors in the crayon box, but it's too many colors. You're going to start getting overwhelmed. So it seemed that 12 worked well. Now, you could argue that maybe there was some Western cultural thing that 12 came up because 12 comes up. There's 12 apostles. There's 12 blah, blah, 12 eggs in a carton, 12 donuts, or whatever. Maybe 12 is they thought was a numerically a, so maybe there was a cultural influence there. I don't know, but it seems like 12 works quite well functionally as well. So this system trades mathematical purity for practical usability. Why does it trade mathematical purity? Because we're not talking in cosmic ratios anymore, although it does have mathematical beauty in that we're breaking the octave into 12 units. The problem is it's not exactly even in the 12 units as we saw, right? We had to fudge it a little, you had to fudging it a little bit to make it work. And then there's a whole history on how they fudged it to make the equal units sound equal so it works right within that system. Okay,